We will start chapter 11 by learning about square root functions and how to graph square root functions. A blank is an expression that contains a radical, such as a square root, cube root, or other root. Now, when I say square root, I mean this symbol, the square root of x. So that would be a radical expression. So anytime you see any type of root, it could also be called a radical expression. A blank contains a radical expression with the independent variable in the radicand. The radicand is kind of like the square root house. So that would be a radical equation. And that's what we're going to be working with a lot in this chapter. So examples of a radical equation could be y equals the square root of x, y equals the square root of 2x, y equals the square root of x plus 2, with 2 on the outside. So basically, any equation that has a radical in it. If the radical is a square root, then the function is called a square root function. And that's what we're going to be learning about this chapter. The parent of a square root function is y equals the square root of x. That's the most basic function that we're going to graph. So let's go ahead and make a table and graph this function and see what it looks like. When making a table, we want to make sure that we plug in numbers that are perfect squares. The reason for this, we don't want to plug in a number like 3 because the square root of 3 equals some type of decimal, all right? And that's kind of hard to graph. But it would be easy to plug in a 4 because we know the square root of 4 is 2. For square root functions, we don't need the plus or minus. I know that we talked a lot about that last chapter, and I'll show you why in a little bit. But we only need to use the positive values. So let's make a table for y equals the square root of x. All right, so I'm going to plug in numbers that are very easy to take square roots of. The first number is 0, because we know that the square root of 0 equals 0. Second number is 1, because the square root of 1 is 1. You can't take the square root of 2 easily or the square root of 3, so the next number I'm going to plug in is 4. The square root of 4 is 2. And then we'll do one more. The next easiest number to plug in wouldn't be 5, 6, 7, or 8, but we can take the square root of 9. And the square root of 9 is 3. So now let's graph this and see what it looks like. So we have to go all the way out to 9 on the x-axis, and up to 3 on the y. So we have our first point at 0, 0. Our next point is at 1, 1. Our next point is 4, 2. And our next one is at 9, 3. So there you go. Now when we connect this function, we have to connect it a very specific way. And it looks like this with the arrow pointing like so. There is not a second arrow down here. And the reason that there's not is because we can't take the square root of any negative number. So I wouldn't be allowed to plug in a -1, and that part of the graph would not exist. So we say that the domain of the square root function is x is greater than or equal to 0. Because we're not allowed to plug in any values that are negative. So that's our domain. Our range is y is greater than or equal to 0. As you can see here, our y values start at 0 and they just get bigger. We're never going to have any negative numbers because in order for this to be a function, we can't have any values down here, or this graph would not pass the vertical line test. So in order for this to be a square root function, we only count the positive numbers. Because if we counted the negative ones also, then we would not have a function. So our graph looks like that. So again, the domain of this function is x is greater than or equal to 0 because we can't take the square root of negative numbers. The range of this function is y is greater than or equal to 0 because we are just going to use the positive values. Let's do another graph and see how it turns out. So we're going to graph the function y equals 3 times the square root of x, and then identify its domain and range. So again, we're going to make a table, and we're going to plug in values that are very easy to take the square root of for x. So here's x, 3 times the square root of x, and y. So again, I'm going to plug in 0, 1, 4, and 9. So we have 3 times the square root of 0, 3 times the square root of 1, 3 times the square root of 4, and 3 times the square root of 9. So you want to always take the square root first and then multiply that number by 3. So the square root of 0 is 0. 0 times 3 is 0. The square root of 1 is 1. 1 times 3 is 3. The square root of 4 is 2. 2 times 3 is 6. And the square root of 9 is 3. 3 times 3 is 9. Okay, so let's make the graph. All right, so my first point is at 0, 0. My second point is at 1, 3. The next point is 4, 6. And then my final point is at 9, 9. All right, and we want to make this curve look very similar to the curve that we graphed earlier. Notice that again, it only has one arrow spouting off in this direction because we are not allowed to take the square root of any negative numbers. So this is kind of the starting point of our function, and then it shoots off. Okay, so again, the domain for this square root function is x is greater than or equal to 0, and the range is y is greater than or equal to 0.